Today we'll be doing differentiation from first principle. Today I will be revealing how the differentiation of sine x will give us cos x. That is, if y is equal to sine x, what is dy dx? We are told that if you differentiate sine x, you get cos what? X. But to many, this is an assumption. They don't know how sine x became cos x. They just assume that if you differentiate sine x, you get cos x. But today, I'll be showing you using the first principle to differentiate sine x so that you will see how we come about cos x. So this is more or less a proof that if y is equal to sine x, dy dx is equal to cos x. Let's see. We are going to be doing this differentiation from first principle, and if you want to do that, we are going to increase y with delta y, we increase x with delta x. So this y I'll write as y equal to sine x. We increase this y by adding delta y. We increase this x by adding delta what? X. When we do this, we are going to collect like terms and say delta y is equal to sine x plus delta x. Let me close it with a bracket. Minus what? Y. Plus y moves and becomes what? Minus y. We say delta y will give us sine x plus delta x minus, what is y? Y is equal to what? Sine x. Okay, at this point we are going to use a trigonometrical identity where we have sine A minus sine B to be equal to 2 cos A plus B over 2 sine A minus B divided by what? 2. If we apply this, you are going to be having that delta y will be equal to, so this is my A and this is my B. We are going to have 2 cos. In place of A, I'll write x plus delta x. And in place of B, I'll write what? X over 2 sine. The same thing, in place of A, I'll write x plus delta x. In place of B, I write minus x over what? 2. Now this will be giving us delta y equal to, we're going to have 2 cos. X plus x will give us 2x, so we can say we're having 2x plus delta x over 2 sine. Now we're going to say x minus x will give us 0, so we'll be left with what? Delta x over what? 2. This will give us delta y to be equal to, these 2 will divide 2x, these 2 will divide delta x, so we're going to have 2 cos, I'll write 2x divided by 2 plus delta x over 2 sine delta x over 2. Now these 2 will cancel this, we're going to have delta y to be equal to 2 cos, I will have here x plus delta x over 2 sine delta x over 2. At this point, we are going to divide both sides by delta x, giving us delta y over delta x to be equal to 2 cos x plus delta x over 2 sine delta x over 2 divided by what? Delta x. If you are still following me, we have delta y over delta x to be equal to cos x plus delta x over 2 sine delta x over 2 over. Now I'm going to write these 2, I'm going to write it as delta x over 2. Remember, this is division, If I want to change division to times, what will happen? These two will multiply the numerator. So we can bring these two down and we'll be having delta x over 2. Now I will write delta y over delta x to be equal to cos s plus delta x over 2. I will carry this delta x over 2 to this side, giving us sine delta x over 2 over delta x over what? 2. Expressing it like this at this point, sine a over a is equal to what? 1. Sine delta x over 2 divided by delta x over 2 will give us what? 1. So we'll have delta y over delta x to be equal to cos x plus delta x over 2 times what? 1. So at this point, we can say that the limit of delta y over delta x as delta s tends to 0 will give us what? Dy dx. Or I can just say as delta s tends to 0, delta y over delta x will tends to dy over what? Dx. What it simply means is that anywhere I see delta y over delta s, I will put dy over dx, and anywhere I see delta x, I'm going to put what? 0. So this is 0 over what? 2. You agree with me that 0 over 2 is 0. 0 plus s is s. Cos times s will give us what? Cos what? S. That is how sin s becomes what? Cos x. If we differentiate what? Sin what? X. Thank you very much.